Hey, hi everyone. So let's discuss about CICD today. So this session covers introduction to CICD. It's one of very important technique that is very commonly used, and it's in like day to day life of a like any software company. Like this is like the core process that is currently being followed. So let's get started. So what is like CI/CD means, like continuous integration and continuous deployment. So with continuous integration, it's basically there are like uh, you have developers in your team. So to make any small changes, they would modify the code and push that code to the central repository. So this process is called continuous integration. So you have like multiple developers, and they would make the change, build the code again, and perform the test. So that part is called integration. And the second part, which is continuous deployment, is basically it's a step further. So it basically means, once all the tests have been passed, you are just moving that code to like publishing that code to the production. So talking about like in any software company. So what do you mean by production? So production is the main the main application that is running and which is available for the customer. So basically, when you build a software, you would perform user acceptance testing before moving to the production, because you want to test with some dummy data, instead of finding those bugs in the production. So for some reasons, if your software stops performing well, the customers would be unhappy, and that would impact your business. So in order to avoid that, you would first perform user acceptance testing, and then once the acceptance testing is done, then you would move your changes to production. So production is basically the actual application that is available for customers. So why it is important? So it's important because let's say you can make changes to a software like very quickly. And let's say if there are any there are any changes in your market, or there is some features that need to be added, and that has come from the business, then you don't want to start everything from scratch. So you would just make like minor adjustment to your repository, and and it allows for us to deliver improvements or fix bugs very quickly. And it also improves product quality, because we can perform we can refine the product in like as time goes on, and we can do like more and more testing. So that's one thing. And also it enhances developer productivity, because it so basically this avoids developers from doing repetitive tasks of like testing, and it would allow them to more focus more on developing the code, making it more precise. So refactoring of the code. These testing and all, like these are like automated testing, so the developer doesn't have to be much worried about these things. It also enables better collaborations, because you get feedbacks and updates like very frequently. So and see continuous integration happens like multiple times in a day, so it's that frequent. and the team can roll back to the previous version if they find any issues. So it's very seamless, and it also facilitates scalability. So usually if you if you enable the automation, you can increase the output, or like let's say if you have a website, if today if there are like 100 people accessing your website, maybe within a week you'll have like 1,000 people accessing the same website. So with CI/CD, if you define once you define the guidelines for testing and the other procedures, it's very easy to scale up and scale down the resources. So as you can see, like this is the comparison between like traditional ways and with CI/CD. As you can see, it is like very much like very much fast paced, and you can make minor changes like once you let's say if you have made, like even if it's there a typo in one of your descriptions, once you update it, you will perform you will perform testing, because like that's the standard procedure. So those minor changes can be done very frequently. So what are the key elements of CI/CD? So the first thing is version control system. You must have used GitHub as your version control system for your projects. So basically, let's say you have made changes and you have realized that the changes are actually those are actually not working as expected, and you would want to revert back to your previous version. So with version controlling system, it's very easy to just roll back to the previous version, and maybe make some changes and take an alternative approach in making those changes. And also another key elements of CI/CD is automated testing. So as I said, for every minor change, you have to perform all the tests, and manually performing these tests requires a lot of time and resources. So with CI/CD, these testing can be done you can have numerous unit tests, and once all those tests have been passed, only then it can be moved to the production. And even automated deployment, there is a way for us to, let's say if you have defined a script saying that if all the unit tests pass, then you can deploy it to the production. So by this, there is no need for humans, there is no need for any human intervention, and the changes can be pushed to production very quickly. So that's one key element of CI/CD. So history, the important thing is Jenkins. The Jenkins is one of very popular CI tools, and you would be using it in your projects. So everything else, you have other tools such as Travis CI, Circle CI. You also have GitLab CI. One important thing I would want to mention is infrastructure as code. So basically, infrastructure as a code is, let's say we were talking about scaling up and scaling down scaling down of a project. So for example, let's say today you have 100 users for your website, and you're using 10 servers to address those 100 users. Maybe next day, maybe next week you have 1,000 users. You would want to increase your number of servers, because if the number of servers are not increased, there is a chance that your servers might crash. So in order to achieve this scaling up and scaling down, you need a automated way to build these servers. So in AWS, for example, or let's say you are just running some Terraform. Like Terraform is one of the infrastructure as code tools. So basically, what Terraform does is, let's say you want to deploy a server. So you give the details such as like this is the operating system, this is the memory, and like it has to like this server has to have data of like pertaining to the website from here, and this server has to be connected to a database. So all those information you write as a code, and whenever this code is being run, you have a server which would be deployed in the backend. So on AWS, it's like very straightforward because you don't have to worry about servers. But even on like your local systems, you can achieve this. It's not challenging, and it's one of major procedures that is like very popular nowadays. So in simple terms, infrastructure as code. Infrastructure is your server, and as a code, like whenever you run this code, you have an infrastructure ready to serve the demand. And microservices is basically Docker containers, Kubernetes. So we'll discuss these things in details later. So, and with CICD, like CICD and IAC and microservices, these are all used in a combination, and it's nowadays it's becoming very like you can't just have like one without the other. So all these concepts are very important. So getting to the key concepts of CI/CD. So basically, as we already discussed, different developers would be merging their copies to the repository like several times. You also have automate building, where like the building process where like it makes sure all the packages, all the code are functioning correctly without any errors. And once this application has been built properly, you would want to test for any bugs. So you have unit tests to perform this perform the testing. So if any of the test fails, like you can it allows you to debug your code. And it's important to maintain the central repository, like main code repository, and with version controlling. And we have discussed like why version controlling is important. So and so the build, you would want to make your build process so efficient that like it's not that tough to make changes. So that's one thing that needs to be kept in mind. So continuous deployment. Again, this is basically like a next step where you would deploy all your code changes to production environment after the build stage, after the build stage, without any explicit approvals from any other person in the team. So you can automate your releases like version 2.1, 2.3. So like that after all the tests have been passed. Having continuous deployment, you would know like the deployment process is going to be predictable, and the risk of facing some issues is like reduced. And it's also important to consider that like continuous deployment, it's usually it's not much so it is not much like it doesn't need environments to be like you can have like JavaScript code, and then you can choose a Python code, or let's say if you're doing an AWS, you can switch to Azure. So like we'll do certain examples, so which allows you to understand this continuous deployment concepts better. So we'll be discussing a few examples. So there is another thing called continuous delivery. So basically, it is continuous delivery is basically like similar to continuous deployment, but you would have a human intervention here. Like, before the deployment is moved to production, there has to be someone from the team who would approve this deployment to production. So that's a small difference. And I would want you to think, like, which of these would be like a challenging thing. Like, is it like a CI thing, or is it like a continuous deployment thing? Like, what do you think is a challenging part? So you can discuss. I mean, you can think about it, and there is actually no right answer, because it depends on your project. So yeah. So what are the benefits? As we discussed, like, we can deliver the product to market quickly, and the product quality is going to be higher. It also increases developer productivity. So these concepts we had discussed earlier. And so yeah, the other thing is like the transparency and enhanced collaboration. So every team knows, like, who has made changes and what changes have been made. So this allows us, like, if this allows us to, let's say if someone else had made changes and they made some errors, you would know, and anyone in the team can rectify those errors. So that's one thing. And as we discussed, like, if you make like frequent and smaller changes, the risk gets reduced. So, and even in CICD pipeline, you have like monitoring setup, let's say if you have some compliance procedures that your company has to follow, you can integrate those compliance policies in CI/CD pipeline, and you can address any issues early. And we also discussed, like, scalability and flexibility. So best practices, we discussed that, like, it's very important to version control everything. So it allows us for, like, easy rollback auditing, and it also allows us to understand the changes that have been made over time. And it's also important to automating the build and deployment process, and separate staging environment. So what staging is basically, it is a stage after UAT and integration testing, but before deployment to production. So you would want to have a environment almost similar to production, but it has all the databases, all the resources connected to production. You would perform the testing there, and once that is done, you can move it to the production environment. So again, like, these are the best practices. So make sure, like, your unit tests have like a wide range of scenarios, so that, like, you can catch any bugs. So we all know, as software engineers, like, it is almost impossible to build a perfect complex software. So the only way to make our software more accurate is by defining unit tests, like various unit tests, and seeing if if our software passes all those unit tests. So the more number of unit tests that you have, the chances of having bugs is less. And it's also very important to monitor and logging everything. So you would want to monitor, because let's say you're using servers, and you don't want your servers to perform about 80% of their CPU or memory usage, because that might lead to crash. So you would want to monitor all those metrics of your resources. And it's also important to log everything. Let's say if you're uh, for some reasons some code failed, so logging this would allow us to exactly pinpoint why this thing has failed, because something else has triggered this event. So we would know what the exact use cases, exact issue is. And again, it's important to make frequent and small commits. And again, we should, for team improvement, we would the team would, it's important to have the team gets their feedback on the changes that you have that they have made. And this way at least we won't be doing very big, very huge mistake, or a huge error, which would result in a very bad software output. So those things can be mitigated by CICD, following these CICD practices. So future trends, AI and ML, as we all know, these are being continuously integrated with CI/CD pipelines. This allows us to write numerous unit test cases. We can also find the patterns and predict maybe potential issues. So that is done, and shift towards serverless and containers. So basically serverless is nothing but if you have used AWS Lambda, AWS Lambda is basically an AWS offering where you focus just on writing the code, and you don't worry about the underlying infrastructure. So the AWS takes care of the server. So it's similar, it's the same thing. So there are servers behind. It's just that we don't have to manage them. It's responsibility of AWS to manage them. And containers, Dockers, we'll discuss in future sessions, what Dockers are and how they are helpful. So these allows us to, Docker and serverless allows us to they offer allow us to scale and scale our application very rapidly. So we don't have to manage servers or infrastructure. So yeah. And as I said, infrastructure as a code is becoming a standard norm. So AWS also has its offering called AWS CloudFormation. And this way, we can do repeatable, let's say, if considering back our example where let's say you have users, and you have once the number of users goes up for your web page, you would want to have same server, but the number of servers should be more. So that's called horizontal scaling. So in that case, every time you want to increase server, it becomes so cumbersome to do the same thing repetitively. So performing infrastructure as code practices would allow us to get rid of those mundane activities. So yeah, microservice architecture. So that's one trend. And security is very important. So it's important to embed security measures from starting of your CI/CD pipeline. So at every stage, we have to make sure our software is constrained in the security guidelines that have been defined. And again, cross-platform CI/CD tools. So we have cross-platform tools, which let's say if you're working on AWS, Azure, it doesn't matter. If you're working with Python, Node.js, or Java, so there are tools which help us to work in like different platform, and this is becoming a norm. So yeah. Popular tools, Jenkins, as I said, it's an open source tool, and you must have already heard about it, and it's a very great tool. I have used a lot in my previous projects. And GitLab CICD, even GitHub has some CICD functionalities. We'll have a in class assignment on this, so we'll be discussing about that soon. Circle CI, Travis CI. These are other tools which does the same thing, and even they are popular in performing CI/CD activities. So Azure DevOps and AWS Code Pipeline are for the cloud services. Now let's work on an assignment, like an exercise on using GitLab. So this is the manual for the assignment we'll be doing, and it has all the detailed steps and how to resolve the issues and issues that you might encounter. So we'll be following this manual for this assignment. So what we'll be doing is we'll develop we'll deploy a simple Python Flask app. So Flask is used to develop APIs in Python. So we'll be developing a Flask app and deploying it on GitHub. And whenever we make any changes to that any code changes to that app, and push it to the GitHub repository, the GitHub would run all the unit tests and tell us whether all the tests have been passed or not. So let me quickly show you. So this is the URL this is the GitHub repository that have this is where the you'll find all the files for this exercise. So as you can see, this is this symbol here represents the status. If it is green and tick, which means when you push some changes, like committed some changes, it shows that all the tests have been passed. But if it shows in red cross, which means one or multiple of your unit tests have failed. So we'll be going through this in detail. So of course you'll need to in order to have work on this hands-on assignment, you need to have GitHub account, and I hope you already have one. Some knowledge of Python and Flask is needed. Again, it's very simple. So even if you haven't worked on these even if you have never used Python, it is straightforward. And you need to install Git. Just Google how to install Git on your PC. So, and this is a repository that I'll be using. So the first step would be to fork this repository. So if you go here and click on fork, if in your account you would be the owner, so select it and name the repository accordingly. So what basically fork means, you're just making a copy of my repository in your account, and you can modify it, you can work on it, you can edit it without affecting my original repository. So you can make a copy and try to update it as per your needs. So create a fork, basically it's creating a copy of the repository in your account. So as I already have this repository, I'll be using this one. So let's go to the manual. So for the steps, so the next step is to git clone the repository. So I have created this empty folder. So I'll try to clone the repository here. So in order to open command prompt with this URL, I mean with this in this directory, I just have to type in CMD in the search bar, and it opens in this directory. So that's one shortcut. So the next step would be to git clone the repository. So I'll just copy this URL. I have git clone is the command, and this is the URL of my repository. So I'll just copy it, go back to command prompt, paste it here, and hit enter. So if you have installed your Git properly and if you have necessary permissions, you shouldn't face any issues. So now let me go ahead and go to this directory. So what I'll do is I'll cd, and this is CICD1. So CICD1. So I'm navigating to the next subdirectory where all my files have been, as soon as I cloned, all these files have been uploaded. I mean, all these files have been downloaded to this local repository. If I, type in dir, basically it's similar to ls, where you list all the contents of the subdirectory. So you can see that there are all the files here. So now let's look at the next step. So as we are already in this directory, we can the next step is to go to this directory, and the first step is to install all the packages. So I'll go here and paste it here. Before running this, let me quickly open the requirements file. So give me a second. So the requirement files has only this. So any package that you mention here, you can define any of the packages that you want to be deployed. You can mention it here. It's straightforward. You just mention the package and its version. So as soon as I run this code, it'll install all the packages. So let me run this. So all the packages have been installed. So let's go to the next step. So now let's open the app, which is app.py in your editor. So I use VS Code because I've been using it, and it's like one of the popular editor. So here, it says hello CICD. So what we'll do is we'll quickly run this app. So the command is python space app.py. So let me run this, paste the command. Okay, there seems to be an issue. Let's resolve the issue. Okay, it says cannot import URL code from this. Okay, so I think I faced the same issue. So let me go ahead and try to run on my editor itself. So yeah, I'm facing the same issue. So let me quickly resolve this. So I think even the document mentions the issue. So let's try to run this command. Let's go back to the command prompt, try to install all the packages. Now run the python app.py. So the issue has been resolved. So if you encounter similar issues, uh, I have mentioned the exact command that needs to be run. So make sure you run that. So now the app is running. So as the document says, if you visit this URL on your local system, you should see hello CICD. So let me run this. So yeah, we can see hello CICD. So now next thing is let's run the unit test. So let me open the unit test file. So this is like a basic unit test file. We are just checking, like, if it prints hello CICD. So let me go ahead and so here what I can do is I'll go here and open a new terminal, or I can use this as terminal actually. And let me paste the unit test command, go back, paste it here. So as you can see, the test was successfully run. So the next step is to change something in the code. So, and we would want to like we are just replicating, like, how your code would be changing, and once the code has been pushed or committed to GitHub repository, the GitHub repository would perform the unit test, and will give you the status, like, has if all the tests have been passed or not. So let's call it hello world. So I have made this change, and this looks good. So let's run the application again. One second. Yeah, in order to stop the Flask app, you have to type in Control C on Windows. For Mac, just Google, like, what is the exact command. So now here I'll run the app again. So it's again running on the page. So now let me refresh. So as you can see that the output has been changed. So now let's go back to the document and see what are the next steps. So now we'll try to push these changes to our GitHub repository. So the first command would be git add. So you can either use command here, or you can use your editor terminal. So let me paste it here, and this command has been run. So let me commit through this command. So it says that, like, 3 files have been changed. So now final step is to push it to the origin main. So yeah. So now if we go back to our repository and see, one second. Okay, let's so yeah, in the repository you can see that it has like a green mark here. So let me run the command. Yeah, so, and if we go back to the repository and refresh the page, the sign has changed because now it's in pending state. But let's give it like a few seconds so that the status changes. Basically, the GitHub is performing your test in the background. So let's refresh it. So yeah, so all the unit tests have been passed. So if we click on it, we get all the details, like, related to, like, what are the steps that have been performed. So like this is the steps that have been performed as soon as we push some changes to the repository. So I'll tell you, like, how, where did we define all these steps. So if you look at the repository here, you have there is this folder called GitHub under slash workflows, and once you open it, you have this .yml file. So all the steps for our CI/CD use case, all those instructions would be saved here. So let's quickly open this file, and this is the format how you write the YML .yml code. And initially you're just installing all the dependencies from the requirement, and then you are performing the unit test. So this script would run every time you make any changes, like every time you push some changes to the GitHub repository. So again, this script would run every time some changes has been made, and you don't have to worry about what are the you don't have to worry about what are all the steps that are being done. You just have to see whether the tests have been passed or not. So that is actually the final step. You can go ahead and run those your changes on local system as well, but like we have already performed that, so we can ignore that for now. So this exercise shows the simple use case of CI/CD on GitHub, and we have successfully deployed a project. We have defined the CI/CD instructions, and every time any change is being made, though that script would run and perform the unit test and give us a status. So yeah, so that concludes the exercise, and this concludes the session. Thank you.